Hi everyone, it's Math with AUB. Let me continue the brief sojourn in the field of conic section. What I have today for you, let's see. Find the equation of rectangular hyperbola. Rectangular hyperbola. Rectangular hyperbola means A is equal to B. Length of transverse axis is equal to conjugate axis. That is the equation. X square minus x square over a square minus y square over a square is equal to 1. Or if transverse axis along x axis. If transverse axis along y axis, then it is to be y square over x square over a square is equal to 1. Right? A is equal to B or B is equal to A. These are the two required equations for rectangular hyperbola. When transverse axis along x axis, when transverse axis along y axis. Look at this. We have plus minus 4 comma 0. It is 40 and negative 4 comma 0 means transverse axis lie along x axis. Transverse axis lie along x axis. So this is the equation. X square over a square minus y square is equal to b square. Y square over b square is where a is equal to b. Means x square over a square minus y square over a square is equal to 1. Distance between these two is 2a is equal to 8. Apply distance formula, you will get, or you can write direct a is equal to 4. Whatever suits you, do that. A is equal to 4. So we have x square over 4 square minus y square over 4 square is equal to 1. Denominators are homogeneous, no change in the denominator, and 4 square will be shifted here, it will become 16. That is the required equation of rectangular hyperbola. And eccentricity of rectangular hyperbola is always under root 2, is always under root 2. And second, we are asked to find the equation of its conjugate hyperbola. Conjugate hyperbola. Conjugate hyperbola to this conjugate hyperbola. Just shift transverse axis to conjugate axis. Just y over y square minus x square is equal to 16. That is the required equation of the conjugate hyperbola to this hyperbola. Conjugate hyperbola of this is this one, and conjugate hyperbola of this hyperbola is this one. Just switch over transverse axis and conjugate axis. The positive one are known as transverse axis, the negative one are known as conjugate axis. Positive transverse axis, negative conjugate axis. There is no comparison of A is greater than B or A is less than B. No. Positive one transverse axis, negative conjugate axis. Positive one transverse axis, negative conjugate axis. And also it is given to us find the asymptotes of rectangular hyperbola. Conjugate rectangular hyperbola. Also find equation of asymptotes. Asymptote means solve for y square minus x square is equal to 16. Constant must be 0. Factorize y minus x, y plus x is equal to 0. Solve for y is equal to x, or y is equal to minus x, y is equal to minus x. These are equation of asymptotes to the hyperbola. Equation of asymptotes to the hyperbola. Always solve for y. Always solve for y. Otherwise, it is given to you find horizontal asymptote. Otherwise, unless it is given to you find horizontal asymptotes, always solve for y. Always solve for y. These are the required equations of asymptotes. All these three answers are mentioned here. Pass me the duster. Question number next. Find the eccentricity of hyperbola whose lattice rectum is double the transverse axis. Okay, let me erase this first. Find the eccentricity of hyperbola whose lattice rectum, length of lattice rectum is double twice transverse axis. Length of lattice rectum is given by either of hyperbola or ellipse. It is same 2b square over a. Twice transverse axis means 2a. Okay, 2b square is equal to 4. Shift a there. 4 times a into a. 2b square is equal to 4a square. Apply table of 2. So we have b square is equal to 2a square. B square is equal to 2a square. We are asked to find eccentricity. Eccentricity of hyperbola is given by c over a. C over a. Equation of eccentricity for ellipse and hyperbola same. The value of c is different. In terms of hyperbola, it is equal to a square plus b square over a. In terms of ellipse, it is a square minus b square, a square minus b square. So instead of b square, I can utilize 2a square. So it is to be a square plus 2a square over a. 1a square, 2a square, it will become 3a square over a. Square root of a square is a root 3a over a cancel out. So our eccentricity is root 3, which is greater than 0 and valid for hyperbola. We have to show that the eccentricities of conjugate hyperbola obey this law. E1 square plus E2 square is equal to product of E1 square times E2 square. Okay. Conjugate hyperbola. What do you mean by conjugate hyperbolas? I have explained several times. Let me give you good idea again. That's equation of hyperbola normally having transverse axis along y-axis. Conjugate hyperbola to this hyperbola is conjugate hyperbola. Conjugate hyperbola means switch over, transfer to conjugate, conjugate to transfer. Means positive term will become negative, negative term will become positive. X square over a square is equal to 1. Okay, cool. Here a is a, and in that case a is equal to b. Eccentricity of this one is given by c over a. It is a normal case. C is c, a is a. It is known as E1, it's E2. C over here, transverse axis is B. Transverse axis is B. So it is C over B. C over B. Now we have to prove that E1 square plus E2 square is equal to E1 square times E2 square. Okay, cool. What is the value of E1? C over A whole square. E2 C over B whole square. Okay. Distribute the square. C square over A square. C square over B square is equal to, taking c square common, we have 1 over a square plus 1 over b square. 1 over a square, 1 over. Taking LCM, we have b square plus a square overall a square over b square. Look at this. According to hyperbola, a square plus b square is equal to c square. A square plus b square is equal to c square. So we have c square. It is also equal to c square over a square into b square. Look at this. It is the value of E1 and its value of E2. It can be written as E1 times square, E1 square times E2 square, E2 square. So this relation in conjugate hyperbola is always valid. The sum of square of the eccentricity is equal to the square of their products. Okay, it's my tiny effort to you guys to explain to you conic section. It's all by itself. Next.